Okay, well, tomorrow is the SAT. I'm not going to see it tomorrow. I know it's going to be super fun for me. I'm going to be able to stand there and do nothing but twiddle my thumbs. It's going to be awesome. It's going to be a very long day, probably even longer for some of you folks who are taking the SAT as well. But you are one of two classes that actually is being displaced. If you are not taking the SAT, then it's a normal day for you. You'll go to your classes. Now, I don't know about your other ones, but fifth period, you're going to go to the gym. Okay. It should be the West Gym, I believe. The gym over there we hold the pep rallies in. I believe that's correct. So the big gym over there, it's going to be Coach Hayes. He does have a roll sheet, so he's going to be taking roll. So please show up if you're not taking the SAT. Now, because tomorrow is the SAT, I'm going to get here early. I'm going up to room 3002 to get it ready. I don't know if it's been prepared yet. There won't be any tutorials tomorrow morning. And I am on campus Friday, but I won't be in class on Friday. So I'm going to not have any tutorials on Friday morning. So the test we just took, if you are wanting to retake it, you have the full week. We come back after spring break. So you have a lot of time if you want to prepare and retake it. In fact, we get back on Monday the 18th, and that Friday the 22nd, by that morning, end of tutorials, that's when the deadline will be for the test. On Friday, I'm thinking I might just go ahead and leave some kind of little in-class assignment worksheet on solving trig equations, just to get a little more practice on those. I'm not going to be assigning anything over the break. Okay, I'm gonna take time. I want to relax, spend time with family. I'm sure you guys want to do the same. So I'm not going to give you anything, but then we come back on the 18th, and we'll go ahead and finish out the school year. Okay. In fact, also on Thursday, you may remember way back at the beginning of the school year, I want to say it was in the first or second week, I gave you what seemed like a district assessment. Okay, it was called a T-test exam. And there was a lot of material on there you didn't know about because we just started the school year. Well, that's what we're doing again on Thursday. It's this Thursday. It's going to be the exact same test. It's part of our appraisal system in Texas we have now. Yeah. It's new this year. It's new this year.
Yeah. Because on Thursday, I have to go and I have to do a timed write, like 4 timed writings that all my other classes, and they were doing that test in that class.
But see, the good news is once you finish, I mean, that's all we got for today, that day. I'm not going to worry about anything. In fact, the only time I'm really going to teach and talk to you guys this week is today, in just a moment.
So for one.
What's what? Yeah, go real quick before we get started. In fact, the new pass is Joker. Yep. One of the students in 8th period lost the red tablet.
How do you lose that?
Very good question. I have no idea. So hopefully it'll be a little harder to lose him. We'll see. Okay, but everybody's okay. If you do happen to forget, I'll have this posted right outside the door tomorrow. So are your other teachers, are they having a lot of their classes move around, or is it pretty much normal? Oh, really? Well, I'm not going to say anything about that because I'm recording, so it'd be nice. I mean, honestly, they should have, because the test is going to go through 6th period. We shouldn't even continue after that. If you're not taking the SAT, you should need to come to school, but I don't make those decisions.
I go to HTC.
That's a good question. We were not allowed to do that. Because we always have to ask permission if we're going to go ahead and do that. And there was somebody at the home office who said, no, students need to be here. I don't know. If it was me, I'd say, you don't need to show up at all. But what are you going to do? Yeah. Start a revolution. There you go. Okay, so. All done there? All right. Well, if you could, go ahead and take out the notes that we've been looking at. That little packet over solving trig equations. I want to go ahead and solve a couple more today to make sure we keep up with it. We're going to have to do probably quite a bit of review when we come back from spring break because I'm not gonna see you tomorrow. We're not gonna talk about it Thursday. I'm not gonna see you Friday. So it's gonna be almost 2 weeks by the time we get back to this material. So I just want to go ahead and do a couple of problems to make sure that we're still up to speed, and then we'll go ahead and call it a day. All right, so let's see here. So far, the majority of what we've been doing is solving trig equations where you just isolate the trig function. You want to get it cosine equals, sine equals, tangent equals. Now, I started out the lesson showing you how to draw the triangles, the special right triangles, that is. We're just going to go ahead and focus on the unit circle itself to help us out. Okay. So let's see here. We've been doing really well on that. Let me go ahead and show you another type of problem. Okay. Now, for this here, how is this one different than the other problems we've looked at so far? It's got 2 trig functions. So see, I can't isolate one without it being in terms of the other. So see, I can't say sine equals without cosine being on the other side. I can't have cosine equals without a sine being on the other side. So there's got to be something I can do. Now for this one, number 7 and 8, they're actually really, really similar to each other. Okay, what you can use is factoring. Specifically, GCF. What does that mean? Yeah, greatest common factor. So you remember we've done this before. Think of the trig function as a variable and just kind of solve from there. So like if I were to say in this case, let's go ahead and keep with the fact, sine is y and cosine is x. So if I were to have 2 times y times x, there's 2 sine cosine, minus sine is equal to 0. Well, maybe this will kind of help you see the idea a little better. You've got a binomial. Well, what do both terms have? What variable? They both have a y. So I can pull that greatest common factor out. If I were to pull out a y, that's going to leave me 2x minus what? That's 0. Because y times what would give me y? 1 equals 0. Now we're going to go ahead and use what's called the zero product property. If you're multiplying 2 or more items and you get 0 as an answer, well, that means I just want to take each part individually and go ahead and set it equal to 0. So see, this is exactly what you're going to do, but you're going to have the trig functions there in place of the variables. So I would say y equals 0, or 2x minus 1 is equal to 0. Okay. Now, let's go back to the beginning. Let's go ahead and use the trig functions. So look here. 2 sine cosine minus sine equals 0. What do both of them share? They both share sine. So just like I pulled out the y, I'm going to go ahead and pull out that sine. So this would be sine of x times 2 cosine of x minus what? What do you think? 1. Because sine times 1 would give me minus sine, right? Equals 0. Now, they don't have to both be groups. Typically, you'll see this when you're dealing with quadratics. You'll have 2 binomials multiplied equals 0, and you'll set them both equal to 0 like you always have. But even if it's a single term, you can still do that. So now I'm going to say sine of x equals 0, and I'm going to say 2 cosine of x minus 1 equals 0. Okay. Well, now, sine of x equals 0, he's already isolated. Okay, we don't have to do anything to him. But over here, we have to do a little bit of cleanup. How can I get that to read cosine equals? So we'll add 1. Okay, so those cancel. So 2 cosine of x is equal to 1. Then Nathan says divide by 2. So cosine of x equals 1/2. Okay. So once you get it to this point, this is where you're going to turn to your unit circle. Okay. Remember, what is sine? Is he the x or the y? Okay, so I'm looking on the unit circle. I want to know every location where there's a y value of 0. So I'm going to come back over here. So looking at the full circle, where are there y values of 0? Okay, so there's a y value of 0, so it happens at 0 radians. There's another y value of 0, so it happens at pi. So those are 2 answers for that one part. So when I come back over here, I can go ahead and say, okay, well, I know that Let me do this down a little bit further. So x is equal to 0 and pi. Now those answers will satisfy this, which means they'll satisfy the original equation. But I still need to find the values that satisfy this part as well. So cosine is the what? Is the x. So it's the same idea. Looking at all those ordered pairs, where do I have an x value that is a positive 1/2? Okay, so here's a positive 1x, so that's a 60. And then there we go, right here, positive 1/2, so 300. But remember, we always want to write our answers what? In radians. So I'm going to say pi over 3, 5 pi over 3. Come back over here, pi over 3, 5 pi over 3. And there you go. Those are all the answers in one revolution that will satisfy the equation. Okay. So how was that? Not too bad? Okay. So that's actually a really good strategy that works a lot. If you have two trig functions, see if you can get everything to one side, maybe pull out a GCF. Okay, see if that works. Okay, so we'll go ahead and try one more like this, and then we'll go ahead and stop for the day. Because the next part will be to start quadratics, but like I said, basically when's the next time I'm really going to talk to you? Yeah, almost 2 weeks. So I'm not going to worry about starting it now, and then, because I guess I'm sure a lot of people are going to go home and study math over the break, right? Exactly, right? Okay. All right, let's look at number 8. Okay, so it says cotangent of theta, cosine squared of theta, equals 2 cotangent of theta. So it's the same type of problem. You'll notice we have just 2 different trig functions, right? Okay. So what if I pulled the 2 cotangent theta over to the left? Now, that's a good question. Would it cancel? It would not cancel because this one is cotangent times cosine squared, so they're not like terms. So I'm going to say cotangent of theta times cosine squared of theta minus the 2 cotangent theta equals what? 0, because those are going to cancel. There you go. Factoring is a really good way to solve these problems if it comes up. Both terms have cotangent. I guess you could say he got caught. It's going to be a while. Okay. So I'm going to pull out cotangent of theta. What would that leave me? So that would be cosine squared. Minus what? Minus 2, and then that equals 0. And see, if you were to redistribute the cotangent, you're going to get the statement we just had, right? So now I'm multiplying 2 items, and I got 0. Cosine things. Now, you can use identities to solve these, but I'm thinking at this point, once you pulled out a GCF here, set each one of these individually equal to 0, just like we did on the previous one. Remember, that's called the zero product property. Lexi. Uh-huh.
Okay, so there's 2 cotangents, and if you factor, it takes all of the cotangents?
Yeah, but see, I can't take out the 2 because that's not common to both.
Oh, my bad. I thought it was 2 separate cotangents, you know?
Well, it is. So one of them was 2 cotangent, but the other one was a product of cotangent and cosine squared.
Okay.
So the only thing they shared was 1 cotangent.
Okay.
So here I'm going to say cotangent of theta equals 0. Now here, if I go ahead and set cosine squared of theta minus 2, is equal to 0, well, what should cosine squared of theta equal? 2. Okay. Now, let's go ahead and take a look at this guy first. Okay. Cotangent is equal to 0. So we're still looking at the unit circle, right? But the only difference now is that you do whatever the trig function tells me to. What is cotangent? It's always what over what? It's always x over y, right? So here's what I'm going to be looking at. When we go back to the unit circle, I'm going to want to find every one of those ordered pairs where I can take the x value, divide it by the y value, and get 0. And there's only going to be a couple locations where I should be able to do that. So where do you think? Pi over 2? So here's the x, here's the y. So 0 divided by 1 is 0, so that's an answer. 3 pi over 2. There's the x, there's the y. So 0 divided by negative 1 is 0, so that's an answer. Is there any other place? Is everybody okay why we're doing x over y? Okay. Now wait a minute, what about 0 and pi? That's exactly right. That'd be undefined. There you'd be dividing by 0, x divided by y. So for that first part, I got pi over 2 and 3 pi over 2. All right, come back over here. So theta equals pi over 2, 3 pi over 2. Okay. Now, take a look at the other one. Cosine squared of theta equals 2. Well, how would I get cosine of theta? Just take square root. So cosine of theta equals the square root of 2, but what do I want to put in front of it? Plus or minus. Okay. So now remember, cosine is the x, so we don't have to do anything fancy here. I just need every location where an x value is the square root of 2. So if I come back over here, look at all those x's. Where? No, just the square root of 2. Well, now, see, this is square root of 2 over 2. It's close, but I want just square root of 2. But you'll notice out of all of those, there is no location that just has a square root of 2. So it's not undefined. It's just that this one is not going to give me an answer. Okay. So the only solutions I have are these guys right here. Okay. In fact, if you were to try and plug that in the calculator, it is going to give you an undefined message. Can anybody tell me what's the decimal value for square root of 2? It's about 1 point what? About 1.41, right? Okay. Think about the unit circle. What is the farthest distance you can be from the center at anywhere on the circle? The furthest you can be is 1. But square root of 2 is larger than 1. So that right there tells me there's no way he can give me an answer. Okay. So this one only had 2. And sometimes that'll happen. Maybe one will not work, but the other one will. Okay. And it is very possible that neither will work. Those do happen as well. Okay. Okay. What do we think? It's easy. That's what I like to hear. Okay. Well, I'm going to go ahead and stop right there. And then when we come back from the break, we'll review, and then we'll start looking at some quadratics.